There are some specifications that make software engineers nervous. Thousands of nodes are distributed massively. Exceptional dependability and accessibility that is needed. Various platforms are available and network expansion is happening quickly, including platforms for hardware that change every few days or weeks till it's time to launch your production platforms into the stratosphere. This is the goal of SpaceX's Starlink initiative, which aims to bring high-speed broadband internet to areas where it has previously been inconsistent, expensive, or inaccessible. SpaceX software developers are some of the most underappreciated tech heroes we have. So, let's look at the mind-blowing software that powers Elon Musk's Starlink. Ensure you watch to the end. Starlink is a satellite network that is developed by SpaceX to provide low-cost internet to remote locations. The Starlink software is divided into two parts, and one is the part of the software that flies, while the other part is the part of the software that supports the flying components, manages the networks, controls the Starlink satellite constellation, which is the constellation of Starlink satellites in orbit, and maintains communication between the constellations and the ordinary terrestrial internet. Each Starlink satellite currently weighs 573 pounds, 260 kilograms, and is about the size of a table. According to Sky and Telescope magazine, satellite internet works by beaming information through the vacuum of space, where it travels 47% faster than fiber-optic cable. According to Business Insider, instead of sending internet signals through electric cables, which must be physically laid down to reach far-flung places, satellite internet works by beaming information through the vacuum of space. Currently, satellite internet is provided by enormous spacecraft orbiting 22,236 miles, 35,786 kilometers above a specific location on Earth. However, when sending and receiving data over such a long distance, there are usually several latency delays. Starlink satellites are designed to deliver vast amounts of data quickly to any location on Earth, even over the oceans and in extremely difficult to reach places where fiber optic cables would be expensive to lay down by being closer to our globe and networking together. Tintin A and Tintin B are SpaceX's first two Starlink test vessels that were launched in February 2018, and the mission was completed successfully. The first 60 Starlink satellites were launched on a SpaceX Falcon 9 rocket on May 23, 2019. The satellites successfully achieved their operational altitude of 340 miles, 550 kilometers, which is low enough for atmospheric drag to bring them down to Earth in a few years, preventing them from becoming space garbage. The Starlink constellation now consists of hundreds of small, low-cost satellites in low Earth orbit, with the business aiming to expand to thousands. As a result, a low altitude is required to achieve minimal latency. Current geostationary satellites orbit at a distance of 26,200 miles from the Earth's core and 22,000 miles above the surface, implying that the signal travels for 0.240 seconds round trip. Starlink is currently orbiting at 340 miles per second, reducing the speed of light lag to approximately a tenth of that. Bond, the network software team's manager, explained that they have a ground cluster of services figuring out who talks to whom in the network, and that their satellites are particularly interesting since they are so close together. A satellite may only be seen for a few minutes as a result of this. As a result, the antenna on a customer's roof must frequently change which satellite it communicates with. Think about how your cell phone talks with fixed towers. Your phone may need to switch from one tower to another on occasion, but the connection is usually stable. Bond explains, one of the major issues for Starlink is that our towers orbit the Earth, causing your internet path to alter regularly. So, he said, his team choreographers this dance by computing desired network topologies, disseminating this plan to network assets, and installing hardware to enable it. The Starlink satellites, on the other hand, pose their own set of issues. Not only is each satellite responsible for maintaining connections to the ground stations in view, but unlike most satellites, the Starlink ones are also largely self-navigating. When hundreds of satellites are launched, there isn't enough time to place each one into its own orbit. Instead, ground control assigns each satellite to a constellation, and the satellite steers itself into position. The Earth-side network then provides constant updates on traffic conditions and constellation changes, while each satellite keeps the ground up to date on its planned path. Bond said scaling this system to many millions of people is a challenge because of the combinatorics of the problem. And to avoid interfering with users, Starlink satellites must paint the ground with data beams of various frequencies, and they'd end up solving a global scale coloring and interference avoidance problem in real life, which is yet another of our major challenges. Starlink software is almost entirely built on C++ on satellites and on the ground, with some prototyping work on Python. The software is created in a continuous integration environment, with teams merging to the master development branch on a weekly basis and developing to the fleet of satellites in orbit. The majority of the vehicle control software is written in C++. It has a long history at SpaceX since it is a very low language that can be used on bare metal microcontrollers. This enables us to use it on our embedded Linux computers, which are installed in all of our vehicles. Dragon and Falcon taught us a lot about how to run a self-redundant architecture on 3 computers that share data and solve the same problems. New code is put through a rigorous testing process that includes everything from simple unit tests to larger scale simulations, from placing satellites to anechoic isolation from ground stations and verifying their communication to presenting the test platforms with a simulation of the whole experiment in which the satellites will function. Some of the most fascinating experiments are listed below. In essence, Starlink has created a simulation to mimic space-time, at least in Earth's immediate vicinity. We have a full-scale network simulation running in continuous integration on a high-performance computing cluster for the development and testing of these algorithms. This simulation can execute both C++ production code and Python prototype code. According to Bond, during the design phase, the Python version enables for rapid iteration. Once we're satisfied with an algorithm's results, we port it to C++ so it may be used in production. One of Starlink's biggest issues is that the satellites themselves are constantly challenging. According to Starlink, they've never had a launch where the constellation satellites didn't alter from the previous launch. This would be a huge issue in most situations. Starlink has addressed this issue by integrating software developers into the production process. Rather than throwing a new hardware over the wall to developers, the software developers are incorporated into the production process to the point of being present on the shop floor. Software is occasionally tested on satellites fresh off the assembly line on their journey to the orbit to ensure that hardware and software are synced throughout the process. The satellite software is packaged for transmission to the satellites once it is ready to launch. Releases are first released and tested on a few satellites in orbit. The software can be reverted if there are any problems. This software is then deployed in an exponential rollout to the other satellites if deemed as satisfactory. Another feature of C++ is its memory management capabilities. You must be prepared for software corruption once you are in orbit, no matter how many times you check the code before launch. What we've established is a core infrastructure that lets us know we're allocating all of our memory at startup. We do it right up front if something is going to fail allocation. Badshaw says. He also stated that they have several tools to ensure that any state that is persisted through the program is maintained in a specific memory location. This informs them that information is being correctly shared among the computers. We don't want a situation in which one of the computers is hit by radiation, a bit flips, and it is no longer in shared memory with other computers, allowing it to run off on its own, right? While SpaceX intends to have as many as 42,000 satellites in this so-called mega constellation, astronomers and amateur skywatchers are concerned that the bright circling objects would interfere with the observations of the universe. Due to the project's magnitude and scope, Starlink on the other hand promises to exceed current satellite connectivity expectations by placing satellites in orbit at lower altitudes than before, 60 times closer to the Earth's surface than regular satellites, according to the business. Because of the low Earth orbit, the Starlink signals have a shorter distance to travel, resulting in less latency. SpaceX had launched over 1,730 Starlink satellites by the end of May 2021. As part of a beta test phase, the constellation is currently offering broadband connectivity in a few locations around the world. What do you think of this outstanding software that runs Starlink? Let us know what you think in the comment section below.